Part 3, let's go. Got number 2 started already. So it says solve triangle JKL. Now for me, my brain goes a little sideways because all of our problems have angle A, angle B, angle C, side A, side B, side C. So we're either going to adapt JKL to this, or we're going to adapt our, anyways, I'm babbling. This is what we're going to do. I'm going to make that A, making this side A. I'm going to make that B, and it doesn't matter, guys, making this side B, and then that makes this side C and angle C and side C. Some other student could have called this C, A, B, or whatever. Formula will correct anything that you change as long as you're focused on side C, opposite angle C, side B, opposite angle B, etc., etc. So now that we have this, we're going to take a look at this situation here, and we're going to focus on the fact that we have angle C, and there's really no way of just grabbing these right out of the air. So we're going to stick with this middle one and see if we can't get by with this. So the area is 1/2 AB sine of angle C. So we got to find side A, side B. How are we going to do that? Well, look at this. That was almost really silly. Everything's given. I just didn't see that coming. I thought we'd have to work to get stuff. But on this problem, they're like, nope. Once in a while, you get some low-hanging fruit, go ahead and pick it. So make sure you're in degrees, so don't ever get lazy and not double check. That could be terrible. So we're going to go sine of 107, 0.956. Now, do not take this 1/2 and distribute it to everything. You'd only do that if it was parentheses and then plus and plus. This is just this times this, which is 7. 7 times this, which is 161 times 0.956. So let's see what we get here. 0.956 times 161, 153.9. So approximately, the area is approximately 153.9 square units, and you're done. All right, let's go on to this one. They gave us a triangle. Find angle C. That means this guy. And find the area. Well, we got all 3 sides. So they said find angle C. So we're going to use this first formula. C squared equals A squared plus B squared minus 2AB cosine of angle C. Takes me a minute. And let's start plugging and chugging. So 14 squared equals A squared plus B squared minus 2 times A, which is 17. Very easy to plug things in wrong. Cosine of C. Now you got to focus on PEMDAS. 196 equals 289 plus 361. This is 34 times 19. 646. So minus 646 cosine of C. I'm going to add these together. So 9 and 1 is 10. 14, 15. 650 minus 646 cosine of C. I hope I didn't make a mistake there. A lot of students are going to focus on this, and they're going to go 650 minus 646 is 4. That is a big mistake. You can't do that. So we're going to get rid of 650, get rid of 650, 196 minus 650, negative 454. So negative 454 equals negative 646 cosine of C. So we're going to divide by negative 646, negative 646. These two negatives cancel. So 454 divided by 646. And I get cosine of my angle is 0.70. I'm going to round it a little bit. Now how do I get home from there? I go second cosine 0.703 Voila, angle C is 45.3 degrees. Put that in my drawing, and we have found angle C. Law of sine, I never mentioned that. Law of sine wouldn't have worked because we don't have any of the angles, so we couldn't use the law of sine. It just wouldn't work. Now that we have that angle, we're going to use this middle area formula again. 1/2 A, which is 17, times B, which is 19, times sine of angle C, which is 45.3. And this is my area formula, so it's going to, all you can do wrong is distribute the half to everything. That's just not a good move. Sine 45.3 times 19 times 17 times 0.5. As long as I didn't type a button wrong, 114.8 square units. So there we go. These problems take a while. So I'm going to read this, pause it, draw a picture, and start. Hockey player attempts a shot. He's 20 feet from the left post of a goal, 24 feet from the right post. If a regulation hockey goal is 6 feet wide, what's the player's shot angle to the nearest degree? Kind of a fun problem. Alright, so here's my drawing. The post is 6 feet wide. He's right here, so I see he's closer to this side than he is to that side, just to make the drawing look a little accurate. And there's my drawing. So the problem is really asking us, what's the shot angle, which is right here. And so that's find angle A. Now we got 3 sides with no angle, so we're going to use the cosine formula that involves angle A. Or I could just switch things around. In fact, maybe I'll do that. I'm going to call that angle C, and I'm going to call this A, and that'll get the job done. So here we go. C squared is 36 equals A squared, which is 400, plus B squared, 576, I hope. I think it is. And minus 2 times A times B, which is 24, cosine of angle A. Whoops, C. We changed it to C. All right. Again, clean this up. 36 equals 976. Let me pause this. All right, they're telling us to leave the building because there's a gas smell in the building, so I'm going to finish this problem. Call me crazy. And then we'll shut this part down and get back to the rest later. So we get negative 940 equals negative 960 cosine of angle C. Divide by negative 960, divide by negative 960. Get out my handy dandy calculator. 940 divided by 960. 0.979 equals cosine of C. So we gotta go second cosine 0.979, and angle C is approximately 11.8 degrees. So my drawing's a little off, but that would be my shot angle right there. Okay, looks like we're starting with vectors, and we got a little bit more left, but they're telling us to leave, so I'm just gonna shut this down just to be a good person. All right, let me know if you have questions.